Hello there. People who were doing hard work to score more marks in JEE and NEET and other competitive examinations will hate this chapter because this chapter in Inorganic will give you easy peasy marks. It's completely giving you just an easy mark, just a tick, your mark is sorted. That kind of chapters these are: P block elements, D and F block elements, and coordination chemistry as well. Today we are going to see how to score more marks in P block elements, how to check, how to get maximum out of P block element marks. Okay, let's get started with the mnemonics because these are the important parts in which element are residing in which group. Address is more important, isn't it? So what is this? The first one, which belongs to group 13. Group 13, what are the elements are there? Bal, gain, Tl. Bal, gain, Tl, which means barium, aluminium, gallium, indium, thallium. Right? Bal, gain, Tl. Okay. The second one, which is group 14, carbon family, which includes Canceli German snatch lead, that is Pb. Canceli German snatch Pb. It means carbon, C for carbon, Silly, silicon, Germans, germanium, snatch, tin, lead, Pb. Okay, Canceli German snatch Pb. Then group 14, that is sorted. Now group 15, new pal assam biryani. New pal assam biryani. So nitrogen family, nitrogen, phosphorus, arsenic, Sb, antimony, and then bismuth. So new pal assam biryani is sorted. Then oxygen family, ho sese chapo. It's like more of an Italian song. Ho sese chapo. Oxygen family, group 16. So starts with oxygen, sulfur, selenium, tellurium, polonium. Then the favorite one, fluffy cat bought an ice at night. Group 17, most of us were very clear with group 17 because we are used to it, that is fluorine, chlorine, bromine, iodine. And lastly, astatine. Then group 18, high near King's zero run, that is helium, neon, argon, krypton, xenon, radar. Right? Let's move on to what we are having in group elements, P block elements. In our syllabus, which includes the electronic configuration, physical and chemical property trends, and that's it. And the first group elements, how it is getting varied, right? So we are going to go through those things, starting with group 13, the electronic configuration. As you can see, 1, 2, 3, 4, 5, 6. As simple as that. NS2, NP1, NS2, NP2. Like that. Exceptional cases, helium here, it is following the full duplet. That is 1s2 configuration. Then, the most of the question asked from the general trends. The first one is atomic radius. Atomic radius, we very well know. We have posted a periodic trends cheat sheet. Within one sheet, you can cover all those general trends. Right? And also, people who have watched till now, we have a little surprise for you. That is, exams are going to come. Any other competitive exams, JEE or NEET, advanced are going to come. We have to practice more, right? So for that, we are going to introduce a mock test series very soon. Maybe I'll attach the test link with this video. Start writing the test. We'll do the paper analysis side by side, we are going to ace this examination, right? Okay, let's get back to the topic. Atomic radius. Atomic radius across the period decreases, and down the group increases. And ionization energy, electronegativity, and electron affinity are almost same. Across the period, left to right increases and down the group decreases. Then metallic character. We all know across the period it will decrease because we know the S block elements are more metallic in nature when we are comparing to P. P are going to more of non-metallic and metalloids, isn't it? Then moving top to bottom, the metallic character increases. Non-metallic character, it increases when we are moving to left to right, and while moving top to bottom, non-metallic character decreases. We saw electron affinity, then oxidation states. It increases in variation in case of moving left to right, and the stability of higher oxidation state increases when we are moving top to bottom. Correct. Then because number of electrons in the outermost shell is getting increased, so that's why the oxidation state is also getting increased. Reactivity, non-metals are more reactive when we are compared to the metal when we are moving left to right. Similarly, moving top to bottom, metals are becoming more and more reactive because the sizes are becoming bigger, so the nuclear charge, effective nuclear charge decreases, which will lead to losing of electron much more easier, which lead to the reactions. Metals are becoming more reactive. Then unique behavior of the first element in the each group. Let's start with the group 13, boron family, Bal, Gain, TL. So where boron exhibits these properties, this is non-metal, forms a covalent bond, which is nothing but the sharing of electron. It does not form D3 plus ions easily. But other groups like aluminium, gallium are easily forming 3 plus groups, right? Then carbon, group 14, first element, forms multiple bond. Carbon is having a special property among all elements in the periodic table, that is catenation property. It can form long chain. It can form many carbons attached, long chain compounds. And then it shows allotropy, like allotropes of carbon are diamond and graphite. Group 15, that is, it exists as N2 due to its strong triple bond between that, and the maximum covalency of nitrogen is 4. Forms 4 bonds. Then group 16, oxygen family, oxygen in the first place, exists as O2 molecule, shows a high electronegativity, forms multiple bonds. Group 17, fluorine, which takes the first place, highest electronegativity, strongest oxidizing agent because it loses, it gains electron. So it itself reduces so that it can act as a strong oxidizing agent. Only exhibits -1 oxidation state. Then group 18, helium. It is a noble gas with only 2 electrons in it, so it will not form compounds, right? It is fully filled, overly satisfied atom. Let's move on to chemical properties. Chemical properties, we very well know about the oxidation state. Oxidation state is nothing but how many electrons it lose or gain to form or attain the noble gas configuration. Noble gas configuration is the destiny for all other elements in the periodic table, isn't it? So group 13 element +3, boron shows only covalent bonding that we know, and group 14 +4 and +2 oxidation states. Lead +2 state is more stable due to inert pair effect? This is very important question. Due to inert pair effect. And then group 15. -3 plus 3 plus 5. Group 15 is for nitrogen family, isn't it? Bismuth 3 plus is more stable than the bismuth 5 plus. What are the letters? What are the points I just mentioned here? All are marks. Okay, so I'm attaching the PDF over here. Just download it, go through it once again, and draw in your examination. Group 16, -2 plus 4 and plus 6. Oxygen mainly exhibit -2 oxidation state. Others are showing +6 as well. Then group 17, -1 plus 1 plus 3 plus 5 and plus 7. Iodine can show +7 as well. Fluorine only exhibit -1 state. Group 18 mostly 0 because they are inert gases, but heavier elements like xenon form compounds +2, +4 and +6. Xenon oxyfluoride, XeF6, XeOF4, XeF2, right? We already saw those in chemical bonding. Then acidic, basic and amphoteric nature of oxides. Acidic oxides. These are important questions. Underline it, please note it down. The question can be asked in the way, which of the following are acidic oxides? Which of the following are not acidic or basic oxides? Okay, or amphoteric oxides. These are very, very, very important. So acidic non-metals like carbon dioxide, nitrogen pentoxide, SO3, Cl2O7 are acidic oxides, and basic oxides are aluminium oxide and lead oxide, where the lead is in +2 oxidation state. Then amphoteric. They are intermediate elements like B2O3, Al2O3. Both are amphoteric oxides. Let's see the reactivity with hydrogens, that is hydrate formation. The stability decreases down the group. For the hydrate formation, the stability decreases down the group, which means NH3 is more stable. Then comes phosphine. Then comes arsenic hydride. Then antimony hydrate. So the stability decreases down the group, and the bond angle decreases down the group due to increase in electronegativity. Most of the question asked from oxides and hydrates part. So please be much more active on that. Then halogens, reactivity with halogens. Forms trihalides and pentahalides like PCl3, PCl5, NCl3, NF3, and then SF6, IF7. So this kind of halogens it can form easily, and the stability of higher oxidation state increases down the group. We saw that in the trends. Then reactivity with oxygen, oxides formation. We talked about this as well. Basic oxides are formed by metals, acidic oxides are formed by non-metals. I'm sure you are aware of what are metals and what are non-metals. In case of amphoteric oxides, which will have the dual nature, acidic and as well as the basic, we saw boron oxide, aluminium oxide and tin oxide as well. Then anomalous properties of the first element. These are the common properties, which is smaller in size, high electronegativity, and strong bond formation like carbon, nitrogen, oxygen. Non-availability of d orbitals, so only s and p orbitals are coming into the picture of bond formation. Then formation of pi bonds. As you can see, C double bond C, N triple bond N, O double bond O, C triple bond C. Like that, it can form a pi bonds between that. Okay. Then uses, mostly uses, it's not in your syllabus, but to people who were aiming for other entrance, you can go through this. Ammonia, for example, it is used in fertilizer. It was used as fertilizers. And nitric acid, explosives, and as well as the fertilizers. Sulfuric acid, these are some important properties which was asked in the previous year papers as well. Battery acid, that is sulfuric acid. Then carbon dioxide, it is a refrigerant, dry ice, fire extinguishers where that is used. And SiO2, glass and semiconductors. Chlorine, water purification, PVC manufacture. PVC is nothing but polyvinyl chloride, right? So chlorine which will be used. XeF2 and XeF4, those are powerful fluorinating agents. Okay, so I told you about the inert pair effect for PB exhibiting +2 oxidation state. So what is that? It is a reluctance of Ns2 electrons to participate in bonding. Due to that, what will happen? Inert pair effect is nothing but the last electrons, the valence shell electrons of Ns2, if that is there in the penultimate shell as well, it is not willing to participate. It will not lose those electrons. That is what the inert pair effect is. Inert, right? Okay, due to that, what will happen? It increases the nuclear charge, and the energy required to promote the electron become significant because it is not willing to participate. So we have to provide more and more energies. And then diagonal relationships. Diagonal relationship exhibited by lithium and magnesium, beryllium and aluminium, boron and silica, right? Which is diagonally opposite in the periodic table, but exhibiting some similar properties. That's what the diagonal relationship means. Okay, so that's it about the overall picture of the P block elements. From 13 to 18 we have covered in just within 20 minutes, right? Now we are going to see whatever we have covered. Let's check what kind of questions can be asked from this chapter. The first question is that which of the following statements is correct regarding the anomalous behavior of nitrogen in group 15, which is asked in advanced. What is the answer to this question? I'm giving you 5 seconds. 1, 2, 3, 4, and 5. So if you know the answer, just put it in the comment. Still thinking about the answer? Let's see the options also. It does not show catenation like phosphorus. It forms pentahalides like other group 15 elements. It has the ability to expand its octet. It shows low electronegativity compared to phosphorus. Out of which is correct? It does not show any catenation like phosphorus. Okay. It lacks d orbital and it cannot expand its octet like phosphorus, arsenic, or antimony. And it does not form the pentahalides also, like because of the absence of d orbital. And nitrogen has a higher electronegativity than phosphorus. So the answer to this question is option A. Then NEET 2020. Among the following oxo acids, which one is the strongest acid? H3PO2, H3PO3, H3PO4 and H4P2O7. The strongest acid which will have what property? The acidic strength of oxo acids depend on the oxidation state of the phosphorus. Think about the oxidation state of phosphorus in each of these options. Yes. So which will give you the answer? Yes. Whoever mentioned the answer as H4P2O7, congrats, you are on the right path. Pyrophosphoric acid is the strongest acid. And what would be the order, which is least? H3PO2. And then comes H3PO3, then H3PO4, and finally H4P2O7. Okay, as simple. Let's say this question asked in JEE Main 2022. Which of the following statements is correct regarding fluorine? It can show positive oxidation states. It has the highest electron affinity among all halogens. It does not form the strongest hydrogen bond among halogens. And option D is it cannot show disproportionation reaction. Again, countdown starts for 5 seconds. 1, 2, 3, 4, and 5. Timer. So which among the following is right? You can close your eyes and take the option D. Because I have told you so many times fluorine can only exhibit -1 oxidation state. What is disproportionation reaction? It's change in oxidation state. Right. So if I'm taking an atom which is in, let's say, chlorine or any other, let's say, manganese, upon disproportionation reaction, it will get reduced and as well as oxidized. It will give you two different products. But fluorine cannot do like that. So it will not undergo disproportionation reaction. What about the other options? It's same as before, -1 oxidation state only. It has the higher electron affinity among all halogens. It's wrong. Chlorine has highest electron affinity. Fluorine is more electronegative. Chlorine is more electron affinity property. Okay. It does not forms strongest hydrogen bond among halogens. It do form HF. It's an example, right? So simple questions can be solved in 5 seconds. Then, which of the following species will undergo disproportionation reaction in aqueous solution? So which is correct? So first one, ClO4 minus, then Cl2, ClO2, Cl minus. Once again, I'm telling you, disproportionation reaction occurs when the oxidation state of an element changes to both higher and lower oxidation state, right? Cl2 and ClO2 show the disproportionation in water, like this. Cl2 with OH minus, it is giving you ClO minus, Cl minus plus H2O. So what is the oxidation state over here of chlorine? That is X. You are taking plus, O minus is there, only one oxygen, so -2, which is equal to -1. So X becomes -1 plus 2, that is +1. Similarly, here you can see chlorine is in -1 oxidation state, +1 and -1. But in the reactant, it is in 0 oxidation state. And if I'm taking ClO2, it can undergo the reaction to form ClO3 minus plus ClO2 minus. Calculate the oxidation state as well. Talking about ClO4 minus and Cl minus. These are already in maximum oxidation state, like for example ClO4, which is in maximum oxidation state, and Cl minus, it is in minimum oxidation state. So it will not undergo any disproportionation reaction. So answer to this question is that Cl2 and ClO2. JEE Advanced MSQ type. Then NEET 2021. Which of the following statements is incorrect about noble gases? They have high ionization enthalpies. True. Xenon forms stable compound with fluorine and oxygen. True. They are monoatomic in nature. Yes. They form strong van der Waals forces due to high polarizability. So which of the following is incorrect about noble gas? Yes, you are right. They form strong van der Waals forces due to high polarizability. That is wrong. The noble gases have weak van der Waals forces due to low polarizability, except the gases xenon and radon. So this is incorrect statement. Then JEE Advanced 2017, which of the following compounds does not exist? Xenon F4. Close your eyes and take the answer. Does not exist. It will not exist, which makes it correct answer. Helium will not form any compound, which is already overly satisfied compound. Then JEE Main 2019. Which of the following is correct trend for boiling points of noble gases? Which will have highest boiling point? Let's check that one. The boiling point of the noble gases increases down the group due to increase in van der Waals forces, isn't it? So atomic size increases so that it leads to stronger London dispersion forces. So which makes xenon is having more boiling point, then comes krypton, then argon, neon and helium. This JEE Advanced 2016, which of the following compounds is not an example of interhalogen compound? What are interhalogen compounds? The compound formed between halogens itself, right? Say for example BRF5, ICl and ClF3. But what about this guy, OF2? Oxygen is not in the halogens. That is different family, isn't it? So it is the answer to this question. Okay, as I told you, mock exam questions are going to come. Please attempt those questions. The paper analysis are side by side we are going to post. Please comment which chapter you want next, which chapter you want to discuss a lot. So let us know, we'll do it, you will ace the exam, we'll help you for that.